So today is video number 68, and I'm not going to do any poems because each time I try to read one of the poems that I like, I found some lines that I need to redo, and this process takes almost the same amount of time which I spent on translating the whole poem. That's why, for example, I want to read aloud this locomotive, but I don't do this because I need some lines to correct, and right now I can't find the right words, so maybe next time. Another idea is that I got some ISO files for Oxford dictionary with all the stuff like the entry for the word, the definitions, the entry for the word, the definitions, and the example of the sentence. There are also the audio recordings of British and American English. And 10 years ago, it was really cool. I used this stuff for some time, but then I stopped. I don't remember why, but I thought that it would be cool for me to go through these dictionaries, learn something new. But the problem is that those dictionaries are essential or advanced, and most of the words from this dictionary I already knew, or the words that I don't know, they are just some specific words from the areas I'm not interested in right now. So, well, I closed another gestalt with these dictionaries, but I have no use of them. All I need I can get from online dictionaries like Oxford Dictionary, Merriam-Webster Dictionary, even Collins Dictionary. They all have the definitions, the examples of sentences, and the audio recordings of the pronunciations of this particular word, and lots of synonyms, and I use them to find the correct word for my translations. Anyway, so right now I'm going to start with my functions. So the function, the task is named find the missing letter, and I have the function find missing letter that takes the array of characters and return one character. And the solution of this task is just one line. So I just need to decipher what this lines does. So what we have here, set char character missing letter. Okay, I'm not sure, I think that all the characters in this array were given in the alphabetic order, and I think they were in the small case, in the lower case. That's why I take this statement, like I got the ASCII value of the first letter, and then I got the ASCII value of the last letter. It's like the interval from the first number to the last number, and I have 3 dots between these two numbers, which means in some particular cases this statement will expand into all the numbers, right? Yeah, like if I have 1.9, then in some statements this statement will be expanded like 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I okay, let me see what I do next. Then I map each of these numbers into the Unicode scalar, and then I convert them into the character. So I don't know, somehow Unicode scalar, and then insert the character. And now I replace each of the ASCII values for the characters in the original array with these characters that were converted from the Unicode scalar. And from these characters I create the set, and then set char array, and then set char array 0. Okay, and then I subtract from this set the set that was created from the initial char array, and I got the first element, which is the character, which is the difference or the missing character in the initial array. So now I understand what is the idea behind all this stuff. The original array starts with A and ends with Z, but somewhere inside the character is missing. Or maybe not. The original array starts with some symbol in the alphabetic order and ends with some particular symbol, like it can start with A and it can end with Z, but it can start with, for example, G, and it can end with W. So there is no guarantee that all the characters from the alphabet, except for one letter, are included in this char array. So we have just some sub alphabet without one particular letter. That's why I take the letters which are the bounds of this set and I use these letters to create the set of letters, which contains all the letters from the start letter to the end letter without any skips or missing or gaps. And then I subtract this full interval of letters. I subtract the original array from it, and I get the only letter which is missing, because we have this letter in our created array and we don't have this letter in the original array. Then we just return the first letter in this set, which is the result of the subtraction. Okay, next, let's go for the next. The task find the missing term in AP. Okay. We have the function find missing. It takes array of ints and it returns int. So what we do here, we take the first, we take the last integer from the array, and we subtract the first integer of this array from the last integer. Obviously we get the difference, and then we divide this difference by the count, by the array size, and then we have the counter from 0 to the array size -1, and we calculate some next value, like the first integer plus the step, and next plus the step. If some particular, find the missing term in the AP. Oh yeah, I think AP means arithmetic progression. So yeah, that's what we do. We have the array of integers which are the terms from the arithmetic progression, from the first to the last element, but we don't have some element in the middle. So we calculate. Yeah. So what I did, I calculate each element of this arithmetic progression, starting with the first element and adding some constant step for each iteration. No, maybe not step, maybe the step delta, some delta, and then I compare the element which corresponds to this iteration in the array, the element in the array which corresponds to this iteration, to the, I compare it with the element next that I got through my arithmetic operations. And if they are not equal, it means that this particular element is missing. Then we return this element. Okay, let's go for the next solution for the task. Find the unique number. Find the unique number. So we have the function find unique. It takes the array of ints and it returns one int. So obviously it returns unique number. And what we have here, we have the Turner operator, which is okay. We have two embedded Turner operators, and the inner one. Okay, it takes two. Okay, count array count. Okay, it takes first and the second element of the array and compares it, and if they are equal, then the first element is returned. If they're not equal, the second or the third element of the array is returned. And in the outer Turner operator, we have this comparison. If the number of elements in the array is even, then we return the first or the third elements of the array. Otherwise, if the number of the elements in the array is odd, we return 0. We return 0, and this is the accumulator. The accumulator for the reduce operation that we do next. Okay, and then we use this XOR operation. We use the accumulator that we get from the first line, and then we XOR it with each element of the array, and obviously in the end we have that unique number that we need to find in this array. Well, actually, I don't really understand the condition of the task from this first line of the function, but I recall that this some sugar syntax sugar about reduce with XOR operator was used when I needed to find the element, some element in the array, the element in the array which we encountered odd number of times, and there we do something like that, but I can't really understand the condition from the solution, but the idea is quite clear. Let's go for the next function. It's more verbose. We have two functions. Good versus evil is the name of this task. So let me see. We have function forces, and obviously we use it in the function evaluate. So I think evaluate is the main function. So we have good which is the string, and evil, which is the string, and we return another string. And good worthies and evil worthies, I don't know what it means, but we have a good array of 6 elements and evil array of 7 elements. Worthies. And then we use function forces that takes this worthies of which are the arrays of ints, and it takes string good or evil, and then we separate this string into elements. Separated by the white spaces, and we maps each of the elements of the string into the ints. So we have the array of numbers, and then we go through all the numbers in this array, and we have the sum of forces, which accumulates the products of worthies and numbers for the particular index. Then we return these forces, and we get good forces and evil forces, and then we have some resolution, array of resolutions, like better result, good triumphs over evil, evil eradicates all traces of good, no victor on this battlefield. And in the end, we use a Turner operator if good forces are greater than evil forces. Then we return the first line about good triumphs over evil. And then otherwise we return another Turner operator, which in the case that good forces are less than evil forces, this Turner operator returns the second resolution, which is evil eradicates all trace of good. And in the last scenario, we return, when good forces and evil forces are equal, we return the third resolution, which is no victor on this battlefield. It's quite a verbose task, but it is quite simple, especially after I walked through the previous tasks and recalled all this Turner operator and other stuff. Let's go next. Help the bookseller. So we have stock list and list of arts, which is the array of strings. Maybe they are the names of these arts. We have list of categories, again the array of strings, and we return something. So we have the guard statement, which checks that list of arts must not be empty, and at the same time list of categories must not be empty, otherwise we return empty string. Next, we create dictionary that maps strings to integers. We go through each category in the list of categories, and for each category And we use each category. Okay, we use each category as the key in the dictionary books, and initialize it with and initialize it with 0. Then we go through the list of arts of art first, and we get array of art, which is the array of strings after we separated the name of some particular art by white spaces. And from the first element of this array of art, we got the prefix, the first letter, and this is our category. And then we take the second element from the array of art, which is the quantity for this category. And now we go through this book's dictionary, and we're using this syntax sugar, where we set the default key, the default value of 0 for the category, for the key, which is category, which we use for the first time. But when the category is already used, we just increase the quantity for this particular category, right? And in the end, we have this output, which is the array of strings, and we go through the list of categories, and we create some specific string like category, colon, and category, colon, the number for this category, and we append this string to the array of strings, and then we just join these strings with the dash symbols, and this is the return string which we return from the function. Okay, it's not very cool, but at least it's quite verbose, and it takes just lots of attention to the details. Next, go with the next stuff. If you can read this, and we have the predefined array NATO, which was get, I think, from somewhere from Wikipedia, where each letter stands for some particular word, so that the operator who tells who spells the specific word to the soldier, I think, the operator can use the words like November, Alpha, Tango, Oscar for NATO, so that there was no question what this word means. So the idea is to write a function to NATO which takes some words in the string, returns string, yeah, and print words, and we takes each char from this string. We uppercase this char, and then we encode it. If it's space, we just skip it. If it's comma, dot, exclamation mark, question mark, open paren, close paren, or the quote sign, yes, quote sign, then we just output this character as it is. Output. We append this character as it is to the array of strings. But if it's just a letter, then we decode it through our NATO dictionary to some word and append this word to the array of strings. And in the end, we join all the words from this array with the white space and return the string. Okay, we have some Mexican wave. Mexican wave. So what we do here, we have the string as the input, and we have the array of strings as the output. We go through each character in the input string. We use the Turner operator if character is white space, then we replace it with the empty string. Otherwise what is okay, otherwise we replace this character with the whole input string, and we append this stuff to our future output array of strings. After that, we go through this array of strings. We go through each element. We take this element, convert it into array, and then we enumerate each element. We go through each char character, and we get the index. And we get this char, and I don't know why, but if the index, what is the index? I don't know, if index equals to I, then we uppercase that letter, that char. Otherwise, we use this letter as it is, but it doesn't, no matter what the uppercase letter or just the original letter is appended to some new word string, concatenated, appended, okay. And then if new word is still empty, okay, if new word is not empty, we append this new word to the new strings array, and in the end we return this new strings array. And there I mentioned the best practice when we go through all the indices of the original string, so it is possible. Then we check whether, wow, through indices, cool. Then we check that each element, each character for the particular index is not white space, and then we call the recursion I'm not sure about what this wave. No, it's not a recursion. It's just some wave append. We get the string, the elements from the original string up to, but without using the last index. Then we uppercase this index with which we work, and then we get the last part of the string starting from the next index and till the end of the string. Wow, that's cool. Okay, so this is, I really don't understand what is the idea behind this code, because yeah, it solves the problem, but I can't understand what was in the original thing. But in any case, it was a good practice just to recall the syntax of Swift and to practice my English pronunciation. And I think I'll go with some with that second lecture on Impressionists that I watched somewhere during the week. So the idea that the first lecture was about the conditions that the art, the painting had before the beginning of the Impressionism, with this classicism and this romanticism, which moved to the side of idealists, and then realists came and Impressionists were from this team. Yeah, but the Impressionists appeared in Paris, and Paris was changed maybe dramatically. Yeah, at by the moment the Impressionism appeared, this all due to the activity of Napoleon III, which was the nephew of the great Napoleon. And Napoleon III was in charge in 1850s and 1860s, and he wanted to return the glory that of the empire that Napoleon brought to France. But after Napoleon was defeated, all this glory was removed from France. All other countries were against France, especially Prussia. And Napoleon III wanted to make France and Paris in particular, the great nation again, but not through the wars, but through the art. Italy was the largest, the major force of culture of painting, of art of painting in Europe, because they were heirs of the Italians were heirs of Roman Empire, which was built on the foundation of the Greek civilization. So Napoleon III wanted to make France at least the second force in painting, or maybe even the first force. And for this, he decided to change the architecture and the style of Paris completely. First, he created lots of boulevards. There were no boulevards before Napoleon III. He just removed lots of buildings and made this broad road that we know right now from the pictures of Impressionists, like Boulevard of Capucines. I don't know the right name, but now no one can imagine Paris without its boulevards, the way we can't imagine Paris without its Eiffel Tower. But when all these boulevards were created, lots of buildings were destroyed and lots of people were left without their homes, and they were moved from the center of Paris somewhere to the suburbs where the new buildings were built and they lived there. Next, Napoleon created at least six parks inside the Paris, because till that moment the city was considered to be the industrial land without any parks, without nature. But Napoleon brought the nature back into the cities, and one of these great parks was created in the place, in the pit from which the stone for these boulevards was taken, and it was the natural something like valley or some pit, and there the park was created. This is the second achievement. Next, he created something like department stores or huge markets, like our Komarovka or Zum and Gum, where everything was inside these pavilions, and everyone came there, bought fresh vegetables, fruits, and other stuff, and went home. But during the Second World War, these pavilions were destroyed. But it was built, and it existed in the culture of Paris of the 19th century. So let me check again. Boulevards, parks, pavilions, not pavilions, maybe some markets with the pavilions. And of course, Napoleon III changed the exteriors of some great buildings. Like he completely rebuilt Louvre. We think that Louvre we know right now was created in its current form at times of Louis the Louis the 14th. Yeah, but no, that's not true. Napoleon rebuilt maybe 3/4 of this Louvre, and I think he started the museum inside Louvre. Also, he changed the surroundings around Notre Dame de Paris, because it was just the huge church cathedral surrounded by lots of I don't know, buildings, other stuff, which came from the medieval culture. But Napoleon removed all these small buildings. He built lots of plazas around the Notre Dame de Paris, and so the tourists could see Notre Dame from every place around it without any obstacles. And Napoleon started to build a great opera house, and it was built during 50s and 60s, and it wasn't finished during his rule, and it was built later, but it was finished later, but now it's one of the greatest opera houses in the world. Of course, it was built like the classical house with the stones, yeah, but inside there were modern structures of metal. So the technology to produce the classical opera house were completely modern for that times. And Napoleon put lots of money into changing Paris. Like the lecturer said, he spent almost trillions on this rebuilding, not just billions, but trillions. And it's such a great sum that for now no other city can be rebuilt the same way. But eventually these changes created the spirit of Impressionists, who were born in Paris and who grew up through these changes. On one hand, the result of rebuilding Paris was positive, because Paris became the capital of art and all this culture of the world. But for the people who suffered during all these reconstructions, through this noise, through this I don't know, trash, while everything was built over and over again, they were not so pleased, because they moved from the places to the suburbs. They waited for these beautiful boulevards and parks to be created. It's like it's cool to have the subway in the city, but it's not really cool to wait for 6, maybe for 8 years while the subway will be finally built, because you need to live with all these routes that were changed, with all this noise, a lot of sand, dust and other stuff from the construction areas. So of course, it's cool when you came to the finished project and you use only the advantages of having this underground. But when you witness during 10 years the construction of the stuff, it's really not so cool. The same way the Impressionists who were born in Paris, who grew up through these constructions, they saw the changes between the medieval Paris and the modern contemporary Paris, and they suffered from all this stuff, as I mentioned, about constructing the metro. And these changes changed really the minds. That's why they became the Impressionists. That's why they became the persons who we know right now as the Impressionists. Well, I think it's not so cool. My today's video was not very cool in terms of fluency, but I think I used kind of lots of ideas. I described in English the code, the ideas behind the code that I wrote a year and a half ago, and I retold this second lecture on Impressionists. Well, I didn't use all the words that the lecturer used. I wasn't fluent enough, but at least I used my active vocabulary and I explained the idea behind this lecture quite well. So with this, I think that this current lecture, this current video number 68 is officially finished.